Welcome to our video series, Easy Experiments to Understand a Complicated Earth. This series is produced by Escuela Nacional Preparatoria and the Centro de Geociencias Campus Juriquilla, UNAM. Hello everyone, especially you who are watching this video. My name is Sandy, and today I have a scientific question to solve. You may have the same one. Would you like to help me? Let's look for the answer. We are almost ready, but what do we need for the experiment? So easy, my friend. One transparent jar, it could be a cup or a vessel. The only condition is that it should be transparent so we can appreciate the phenomenon. A glass dropper, if we don't have it, don't worry, we can use the cap of a pen or a transparent straw with Play-Doh. We also need a balloon and a pair of scissors. Are we missing something? Let's check our list before we start. So now that we are ready, let's go! Let's make science! First of all, fill the jar with water, then put the dropper in. Stretch the balloon so that you can cover the top of the jar. You can cut the top of the balloon to adapt to the size of the jar opening. You can use a garter to sustain the balloon. Start pushing the balloon downwards. The air inside the jar pushes the water inside the dropper, so water continues up and up. Why does water go up? Let's see it again. Let's make zoom. You might be thinking, what happened in our experiment? Well, let's find the answer. And for that, we will use our amazing blackboard. Come on! This phenomenon was explained by Pascal, and to understand his theory, first we need to understand what is pressure. Pressure is a force on a specific area, for example, between the microscope and the table, or the pressure you apply on the floor. Total pressure is the addition between atmospheric pressure and fluid pressure. Knowing this, he states that if an external pressure is applied to a container fluid, the pressure in the fluid will increase, which takes us to an interesting relationship. The bigger the force you apply, the more pressure would be found in the fluid. Of course, the pressure in the fluid will try to find a balance, which is the reason of why the fluid will go in various directions. If we have a very intense pressure, the fluid could go up or will come out by making a hole or holes, depending on the pressure, in the material. So, when we see fluids without movement, means there is a balance. However, when fluids have movement, a balance is trying to be found. This pressure or force could come from objects, our hands, or could be found in nature, like atmospheric pressure or gravity. An example of this phenomenon is the syringe, and also in the pools. However, do you know the quantity of the fluid that goes up or comes out of the container? It's an interesting question, and what Archimedes found is when we put an object, the liquid will show an aqueous force, in contrast to the force of the objects, the atmospheric pressure, and gravity. In order to find a balance, the object will be in certain point. Depending on the object, would be the quantity of fluid that goes up or comes out of the container, as you can see here. Let me ask you a question. Do you think we can see this phenomenon in our daily life? Of course we can. We can see it in balloons, in sports like diving, or even when we take a shower, like Archimedes said, Eureka. Also we can see it when we get a machine. So it's everywhere. Finally, do you think boats float? Does this have a relationship with the phenomenon? So, as Archimedes has said, Eureka! We have found the answer. Let's continue searching. Be curious. See you!